Hi, everyone. My name is Madhura Bhave, and I'm a developer on the Spring Boot team. So today I want to talk about what's new in Spring Boot 2.0. We spoke a little bit about it in the morning at the keynote session, but this session will sort of be a deeper dive into some of the things we covered in the morning. So just with a quick show of hands, how many people have tried out Spring Boot 2? Okay, wow, that's quite a few. And how many are still using 1.5? What about 1.4? Okay, so half and half between 1.5 and 2 are okay. So the agenda for today roughly looks like this. We'll go in a little bit into what's new in this release. And then we've also redone some of our core parts. We've rewritten a lot of them. So we'll look at how things worked in the 1.x line and how that compares to the 2.0 features. So with a major release, we always have an opportunity to upgrade our underlying infrastructure. And one of the big things for Spring Boot 2.0 was that we've shifted the Java baseline to Java 8. So Java 6 and 7 are no longer supported. And Java 8 is the baseline for Spring Boot 2. We also have the opportunity to upgrade our third-party libraries, since they also come up with their major versions. And for Tomcat, these are just a few of them. So you can find an entire list in our release notes. For Tomcat 8, you now require Tomcat 8+. For Timeleaf, it's Timeleaf 3 and above. And for Hibernate, it's Hibernate 5.2 and above. The next big thing for Spring Boot 2.0 was upgrading to Spring Framework 5. And Spring Framework 5 actually brought with it a lot of exciting features. And one of the big themes for Spring Framework 5 was Reactive Spring. So reactive programming, you must have heard a lot about it even at this conference. It's a new way, it's a way to write your applications in a completely non-blocking and asynchronous manner. So what's the difference between a blocking and a non-blocking application? In a traditional blocking application, you typically require a large thread pool because each request gets its own thread. But in the non-blocking world, you're not allowed to block any thread at any point. So typically, it's one thread per CPU core, so you have a much smaller number of threads. And as soon as the results are ready, because no thread is blocking at any point, worker threads go and process those events. What does that look like in the Spring world? So for the blocking application, you have your traditional servlet stack that you see on the top. So you have your servlet containers, such as Tomcat. On top of that is the servlet API, which is blocking. And then you have a framework such as Spring MVC sitting on top of that. But in the reactive world, since you're not allowed to block at any time, we don't use the servlet API. So the underlying, instead of the servlet container, by default in Spring Boot 2, if you go for a reactive application, we use a non-blocking runtime called Netty. You can also use Tomcat, Jetty, and Undertow. But in this case, we'll use the Servlet 3.1 non-blocking API. And on top of that, because we don't want to use the Servlet API, there's a reactive HTTP layer that sits in the middle there. And then the web framework, instead of Spring MVC, we use Spring Web Flux, which was introduced in Spring Framework 5. So let's take a quick look at a demo for how you can write a completely non-blocking application using Spring Boot 2. Is that font visible at the back? Thanks. So what I have here, it's just a bunch of commits lined up, and I'm going to check out each commit. So we're going to start off with a blocking application using traditional Spring MVC, and then slowly we'll build our way to a non-blocking application using Spring Webflux. So this is the POM for this application. It's using Spring Boot Starter Web, which will use Tomcat by default, and we're using MongoDB just to store some data and get that in our MVC application. So if I run this application, I guess I have something running on port 8080, sorry. OK, let's try that again. There we go. So if you see here in this long list of logs, the application started on Tomcat on port 8080. And if I clear this, the application is a really simple Spring Boot application, so I'm not really going to walk through the whole thing. But it's got this one controller called the cities controller. And it has an endpoint that returns a list of cities. These are the cities that, on application startup, I stored it in the embedded MongoDB. And for that, we're using Spring Data's CRUD repository interface, which gives us a whole bunch of nice things. So if I curl the cities endpoint, you can see that it's returning a JSON array of the cities that we stored in the database. And if we take a quick look at the logs here for the servlet container, it's using this one thread entirely for the entire request. So there's no so for the one request that we made, the entire request is carried out in that one thread. Now, what I'm going to do is stop the application first and switch to a reactive repository. So instead of Spring Boot Starter MongoDB, I've changed it to a reactive MongoDB. And the difference here is now the repository, it's going to give us a flux of cities. So what does that mean? A flux is a publisher from Project Reactor. And Project Reactor itself is an implementation of the Reactive Streams API. So in the cities controller, you'll see a difference. So instead of returning a list of cities, we're now returning a flux of cities. So the flux is the publisher, which will give you the data. And if I run the application now, it's still going to start up on Tomcat, because we're still using Spring MVC, but we're using Spring MVC with a reactive data repository. So just a quick look to make sure it started up on Tomcat. So it's still starting on Tomcat, but you'll see a difference in the threads when we curl the cities endpoint again. The result is, again, the same. It's a JSON array of cities. But if you look at the request here, so it started off with the servlet container thread, and then Spring MVC actually saw that the controller was returning a flux of cities. So what it'll do, it will subscribe to this publisher, and it leaves the request unbounded. So once it gets all the data from MongoDB, it actually dispatches back to the servlet container thread here. So here you can see that until this point, it's one servlet container thread. And then Spring MVC subscribes to the flux, you get the data from MongoDB, and then it dispatches back into the servlet container thread. So it's a little bit of a dance between the threads going on over here. Because this is sort of a hybrid model. You have Spring MVC, but you have a reactive data repository. Now, the last thing here is we're going to switch to a fully non-blocking application. So instead of Spring MVC, we're using Spring Boot Startup Web Flux. And this has converted our application now to a fully non-blocking application because we're using Web Flux. The default runtime that you get with Spring Boot Startup Web Flux is Netty. But like I said, you could still continue using Tomcat, Jetty, or Undertow. So if I run the application now, it's using Netty instead of Tomcat. And I'll call the cities endpoint again. We still get back the same result. But now if you look at it, there's no switching back and forth between the threads. Actually, these threads that you see here, that can be a little confusing because I have a different application that's constantly polling port 8080, but our request has actually ended here. So there was no need for Spring Web Flux to subscribe to the flux or anything, like Spring MVC did, and it switched between the servlet container threads. So this was pretty straightforward. OK, so that was just a quick demo of how you can write a completely non-blocking application with Spring Boot Startup Web Flux in Spring Boot 2. Just a few points about Reactive Spring in general. It's non-blocking. There's an event loop at the center, and you have these worker threads processing the events. One thing to keep in mind is it's more for scalability than speed. A lot of people get confused and think that reactive programming is all about speed, but actually it's more for scalability. And you can still use Spring MVC. So it doesn't mean that just because we've introduced a new web framework, that is the way that you have to go. It might not make sense for your application to use Spring Web Flux. You can still continue using Spring MVC, and it's fully supported by Spring still. The next big thing that was new in Spring Boot 2 was Micrometer. So in Spring Boot 1, we had some basic metrics. But in Spring Boot 2, we've actually provided auto-configuration for this new project called Micrometer. And Micrometer is basically a metrics instrumentation library. So in Spring Boot 1, we had hierarchical metrics. But with Micrometer, you actually get dimensional metrics. So you can drill into your metrics and get more information. You can even send your metrics to various backend systems, such as Datadog, Atlas, Prometheus, New Relic, etc. And I have a quick demo for Micrometer. I'm not really a metrics expert, so I won't be able to go into a lot of details. But it's really cool to see that how you can just quickly configure the registry or the implementation that you want in your POM, and you'll see the metrics being routed to that system. So in the same application, I've changed the POM and added Spring Boot Starter Actuator. So you need Spring Boot Starter Actuator, and you need the dependency for the metrics the backend implementation that you want to send your metrics to. So in this case, we're using Prometheus. And in the application, one thing that I've added is this metrics registry customizer. So for every implementation that's supported, Spring Boot will register a metrics registry. And you can customize that registry using the metrics registry, the meter registry customizer. So here I've just added some common tags for all the metrics collected, which you can then use for filtering the metrics in the system. So let me just run this application. So if you notice here, there's this Prometheus endpoint registered under the actuators base path. And that's the endpoint that Prometheus will scrape the data from. And I'm going to use Grafana in the demo to show the visual metrics. So this is Grafana, and it's getting the metrics from the city's application. You can see some core metrics here that are available to you. There's JVM metrics. There's also additional metrics for garbage collection, class loading. There's also some file descriptor metrics somewhere, yeah, here. So, and here we have some metrics for the city's API. There is a load tester application that I have, which you can run. I'll put it up on GitHub, and you can see the metrics here. I'm not going to run it right now because I only have 50 minutes to cover a lot of things. So this is just a quick way to visualize some of the things that you can get with Micrometer. Let me stop the application. OK, so that was a little bit about what's new. But what's changed? There are a few things that we've changed in Spring Boot 2. And one of those is configuration properties. So we've had configuration properties since 1.x. And basically, configuration properties, for those of you who haven't used it or haven't heard of it before, it gives you a nice way to bind your application properties to classes. And you can use this thing called relaxed binding. So we'll just take a quick look at a demo for configuration properties. I'm going to first show you how things were in 1.x. And then I'll show you how they've changed in 2.0 so you can sort of compare that. Right. So again, I have a list of commits. I'm going to walk through them. This is a 1.x application, 1.5 application. And we have this hello properties, which is a configuration properties class with a prefix of hello. And it has a list of strings with a default value of A and B. Now, one of the problems with configuration properties in the 1.x line was that the behavior with lists was quite unpredictable. We got a lot of bugs related to lists and how the behavior was confusing when people were trying to bind properties from YAML files to lists. So let's just take a quick look at what was unpredictable and why was that confusing. So I have this application.yaml, and I want to set the property to C for the list foo. But if you look at this test, I'm asserting that the list should contain exactly C. What do you expect will happen? Anyone wants to take a guess? So in Spring Boot 1.x, it actually did some weird merging of lists, and the actual value in this case was C and B. So if you notice here, the default values were A and B, and in our application.yaml, we had C. So I would expect that C would override the entire list and not just replace the first item in the list and merge it. But that's what it did. On the other hand, if I didn't use a YAML list, and if I used just like a comma-separated list of values, this test would actually pass. So there was a difference in behavior depending on whether you configured your properties using the YAML list format or whether you used a comma-separated list of values. So that was confusing to a lot of users. On the other hand, if you look at Spring Boot 2, so this is the same application. I have hello properties, but the only difference is that it's using Spring Boot 2. It's literally the same test. And let me show you how it works with the YAML list. So using a YAML list, I expect that C will entirely override the value for the list. So that passes in Spring Boot 2. And also, if you use a comma-separated value, it's going to behave the same way. So there's no unpredictability going on here, depending on how you specify the list. I'll run it just to be sure. Yeah, so it's green. Again, switching back to the 1.x application, the next thing that didn't work in the 1.x line was binding to sets. So we just didn't support that. So I have a set of strings here called bar. And in my application.yaml, I'm trying to bind these properties to that set. But this test bar should contain cat, dog, and bird. If I run it, it fails. It fails with an exception. So it was just not supported. But in Spring Boot 2, if I run the same test, it's green. So we actually do support binding to sets. You can use the YAML list format, or you can use comma-separated values. I do have a commit here for binding comma-separated values to the set, but I won't run it. It works. The next thing that we enhanced with configuration properties was we added origin support. So a lot of times when debugging your application, it's useful to know where a certain property came from, which file it came from, what was the line number, etc. And now we actually store that information when we create the property source for the YAML files and the properties files. So for demoing this, I've added the Spring Boot starter actuator to this application so that we can look at the env endpoint. The environment endpoint is an actuator that will show you the Spring environment. And we use the origin information in the environment endpoint. So if I just quickly run this application. And if I hit so if you notice, the actuators are under the actuator base path now in Spring Boot 2. That's one thing that's changed if you're migrating from 1.x to 2. Let me filter by one of the properties. And if you see here, it's actually telling you exactly which line and which column number this property came first. So it can be pretty helpful for debugging. And maybe going forward, we can use it for other things. But in Spring Boot 2, we've exposed that via the environment endpoint. What's next? Right. So there's another enhancement to the configuration properties that we've provided, and that's support for duration properties. So it was initially, like before 2.0, it was pretty tedious to bind values to like time-based values. But now we have this duration type, and you can actually bind using this simple format. So 6,000 here, the default unit is milliseconds, but you can change that using this annotation called duration unit. So you can actually say that for this property, I want the default value to be whatever you want it to be. And just to show you how it works, that it works, not how it works. I've set 6,000 in my application.yaml file, and I'm saying that this property should be equal to 6,000 milliseconds. So the test is green. So it's just a really convenient way of binding properties to your duration properties. You can even specify it as 6,000s or milliseconds. But by default, it's milliseconds. Right. And the last thing I wanted to show you in configuration properties is we have introduced a uniform format for reading properties from the environment. So in the 1.x line, if you wanted to read properties, you'd have to use this class called the relaxed property resolver, so that it would sort of give you a way to use any of the camel case or the snake case or kebab case when reading the properties. But in Spring Boot 2, when you read properties, you can directly read them from the environment. So even though I have specified it in camel case over here, when you read it from the environment, you can use this uniform format, which is actually I'll go into the details of the uniform format in the slides because there's a few points to that. So you don't have to remember or know how a property was specified in a properties file. When you're reading it, if you just use the uniform format and get it directly from the environment, that should work. Right. So just recapping what we saw, the relaxed binding rules, they stay the same. So in your properties files or in your YAML files, you can still continue using either hyphens or camel case, underscores, whatever you prefer, and that will get bound properly to the configuration properties class. But when you're reading properties from the environment, we prefer the uniform format. So what is that? That's the elements are separated by dots. It must be alphanumeric, must be lowercase, and you can use hyphens to separate the word. So like we saw in the demo, separated by dots, and we're using hyphens to separate the word. So the other cool thing is now you can actually specify indices in environment variables. We've added this new format with underscores. So when you're specifying properties via environment variables and you want to bind to a list or something, you can use an underscore. So my_foo_1 will actually map to my.foo of 1. Because with environment variables, it wasn't possible to do that before 2.0. We have consistent behavior for collections, better types, for example, duration, and the origin support. In Spring Boot 2, we moved a lot of our properties, like we moved them under a different namespace. So if you were using, let's say, server.port, I think now that's moved to server.servlet.port. If I'm, actually, I think it's server.path. I don't remember, but there were a lot of properties that are moved to a different namespace, And when you're migrating your app from 1.x to 2.0, it can be a pain because you don't know which properties have changed, how do I know if my properties are working, etc. So we've added this properties migrator, and all you need to do when you're migrating is add this dependency. The migrator will then give you, will show you which properties have changed in Spring Boot 2.0. So if you have a property in your, let's say, application.yaml file that's no longer valid in Spring Boot 2, the migrator will show you that it's no longer valid. It will also temporarily change it for you. But the next time you run the application, you should fix that property and remove the migrator. So it's convenient for people who are migrating from 1.x. The next thing that we really redid in Spring Boot 2 was the Actuator Endpoints infrastructure. So Actuator Endpoints, they give you a way to manage and monitor your application. There are a bunch of inbuilt endpoints such as health, env, info, and you can also add your own actuator endpoints. Again, we're going to look at the comparison between the actuator endpoints, how they worked in 1.x, and how they work in 2.0 now. How many of you write your custom actuators? OK, not too many. Sorry, I think I closed the window. Just give me 1 second. Right. So this is, again, it's a 1.x application. And we have the Spring Boot Starter Actuator dependency. And if you wanted to write your custom actuator in Spring Boot 1.x, we had this endpoint interface, which you would have to implement, and override this invoke method. So I've added a custom actuator called example endpoint. And if I run the application, you can see that it's registered this example actuator. But in Spring Boot 1, if I wanted to add something more to this actuator, there wasn't really a way to do that conveniently. I've added this method called setSomeValue because I want this actuator to actually go and, let's say, change something. So for example, we have the loggers endpoint, where you can actually change the logging levels of your application at runtime. But obviously, if you see here, this I've added the method, but it's not really going to do anything. So you'd have to add adapters for this method. And for MVC, you'd need one adapter for exposing this actuator over MVC, and you'd need a separate adapter for exposing this actuator over JMX. So as you can see, it's kind of tedious and not very user-friendly. But if you look at how you can achieve this in Spring Boot 2, still have this example endpoint. But instead of the endpoint interface, we now have this endpoint annotation. And the ID of the annotation is what's going to be used as the path for the endpoint. So this will be mapped under /actuator/example by default. And we have these technology-independent operations. So we have a read operation, there's a write operation, and we have a delete operation. So for the MVC ones, the read operation will get mapped to an HTTP GET. The write operation will be an HTTP POST. So you don't really have to add these technology-specific adapters. You can just do that in this endpoint class. But what if you did want to have some different behavior for the web actuators? We have these extension annotations. So there's an endpoint web extension, and you tell it which endpoint you want to extend. So the difference between the endpoint web extension and the actual endpoint is this one is saying hello web world. I'll just run it really quick so that we know it's working. There's also, if you wanted different behavior over JMX, there's an endpoint JMX extension, so you can change the behavior for the endpoint when it's over JMX. So if I go to example, it's going to say hello web world, because that's what we've changed the endpoint web extension to behave. One of the cool things about the new actuator infrastructure is that it just does anybody use Jersey? OK, so maybe it won't make a difference to you. But for those of you who do use Jersey, it actually just works out of the box with Jersey. So I've changed Spring Boot Starter Web to Spring Boot Starter Jersey. And I don't have to do anything additional. This actuator will just continue working as it was working with Spring MVC. And same for Spring Web Flux. It'll just work out of the box. So if I just run it really quickly. So it continues working. OK, so recapping what we just saw, we have new annotations for adding custom actuators. There's tech-independent operations. So if you don't want to change any behavior, depending on whether it's web or JMX, you can just use these tech-independent operations. And we have tech-specific extensions for extending a particular endpoint over a given technology. Andy Wilkinson is actually doing a talk, a deep dive into mastering Spring Boot's actuator tomorrow. There's a link to his session at the bottom of the slide. So if you're interested, it'll be a really good talk to understand the actuator infrastructure well. So like I said, it works with Spring MVC, Spring Web Flux, Jersey. For the health endpoint, which collects information from a number of health indicators, for a Web Flux application, we have support for reactive health indicators too. And we also changed some of the response structures for the mappings endpoint and the trace endpoints. So if you were using something from 1.x and you're moving to 2.0, you'll see a difference there. Right, so security. Security was also changed pretty drastically in 2.0. And the problem with the 1.x security was that we did a lot out of the box. So Spring Boot would provide, if you had Spring Security on your class path, Spring Boot would provide auto-configuration for the application. And by auto-configuration, I mean we would add a web security configurer adapter. If you had the actuator dependency on your class path, we'd provide an additional web security configurer adapter. And then if you added your own custom security, you'd have all these ordering issues for these web security configurer adapters. And we found that there was a lot of confusion about, people were getting confused about when security would back off. They'd expect that, OK, they've added their custom security, so that should be the only source for the security configuration. But it wouldn't work that way, because since we had these two separate web security configurer adapters, the actuator one wouldn't back off as expected. And in Spring Boot 2, we've really tried to simplify the way Spring Boot security works out of the box. So we just rely on Spring Security's defaults. We have one web security configurer adapter for both the application and the actuator, if the actuator is on your class path. And hopefully that makes adding custom security easy. And there's no ordering issues with web security configurer adapters. We have added convenience. So for those of you who use the actuator and were relying on Spring Boot's separate auto configuration for the actuators, when you add your custom security, we've now provided convenient methods for you to configure your actuator security, which I'll show you in just a bit. And we also have, if you're using a WebFlux application, we also provide security auto configuration out of the box for the WebFlux application. So I just have a small snippet of what your custom security configuration might look like. So this is the web security configurer adapter that I was talking about. And these endpoint requests, this class, is a convenient way to add matchers for your actuator endpoints, or for, well, this is path request, even static resources. So this add common locations will give you a request matcher to all the common locations where your static resources might be. So you don't have to hard code them in here. And let's see, so if we just look at this one really quick, what this is saying is, for any request that goes to the health endpoint or the info endpoint, do not require authentication. But for any other actuator endpoint, require the role admin. And for all the static resources, don't require authentication. So this is just an example of how you would configure your custom security configuration and have it all in one place. And the last thing I wanted to mention was OAuth. So in Spring Boot 2, we're now relying on Spring Security 5's OAuth configuration. So Spring Security OAuth has actually folded into Spring Security 5.0. So we're just providing auto configuration for what Spring Security 5 gives us. So now there's support for multiple client registrations. And however, the authorization server and resource server support for OAuth is not yet in Spring Security 5. So if you were relying on Spring Boot's authorization server and resource server, you have to include this additional jar in your project, which I've linked to at the bottom of the slide. It should be, I think the resource server support is actually going to make it to Spring Security 5.1. So once that is there, if you're using the resource server, you won't have to include this additional jar. But until then, you would. Just one more thing to keep in mind if you're using OAuth and migrating from 1.x to 2. And I think that's all I have for today. So thank you.